Hello, welcome back to the channel. So let's do a graphical version of the comparison test and solve this question, which is based on identifying functions based on the given conditions given in the question. So in this question, we have been given the sketches of two functions y equals fx and y equals g of x, and we know that the integral from 0 to infinity for fx dx converges, but the integral of g of x with the same endpoints with the same interval diverges. So assuming that the sketches or the graphs continue as shown in the picture, we have to identify which graph is f of x and which graph is for g of x. So based on these two curves and also based on the given criteria, given condition given in the question, you have to identify which curve is fx and which curve is g of x in this case, right? And we'll do that based on what we know about comparison test. So if you have not watched my previous videos on comparison tests, I'll highly suggest you to first watch those videos in order to get the full idea about this question over here. So now let's see what's happening in this graphical representation over here. So we can clearly see that for large values of x, we can see that the blue function is greater than equal to the red function over here, right? And that is only applicable for large values of x, right? So we can clearly observe this fact over here that for large values of x, our blue function is always above the red function over here, right? So based on this given information, if we assume our blue curve to be f of x and our red curve to be g of x, we know that the area under the curve from 0 to infinity for f of x dx has a real solution to it, right? If it converges, we know that the area under the curve has a real solution. So if that's the case, if this area under the curve converges, then based on comparison test, g of x will also converge, right? So that is why in order to make both of these conditions true, we'll have to swap these two functions. So the blue function will be g of x and the red function will be f of x. Because by comparison test, we know that if this area under the curve for the blue function converges, then the area under the curve for the red function would converge as well, right? That is what we already know based on the knowledge of a comparison test. But since this is not what we want based on the question, our areas, our functions will have to be swapped. So g of x will be the blue function and f of x will be the red curve over here. And that is only because even if f of x, the area under the curve for f of x converges, we cannot necessarily say that the g of x area under the curve, which is greater than the f of x area under the curve, will also converge. So that is why the only possibility for these two conditions to be true happens when the g of x is the blue curve and f of x is the red curve over here. And that is what you can also confirm from the solution of this question. You can clearly see that for large values of x, your red function is always less than equal to the blue function. So the red function, for large values of x, the red function is always less than equal to the blue function, right? And now by comparison test, we know that if the blue function's integral converged, the red function's integral would converge as well based on the comparison test, right? And since based on the requirements of our question, one integral converges and the other integral diverges, there is only one possibility, which is for the blue function to be g of x and the red function to be f of x in this case. So that's it for this video. This question was based on comparison test, but on a graphical representation version of the comparison test in this case. So feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.